Hello. Hopefully the sound works. Cool. Okay, hello people. Welcome to the second live stream lecture. Cool, just checking that the sound worked and some other things, but we should all be good to go. Okay, there's going to be 3 parts of this lecture. Part number 1 is going to be average rate of change. Okay. Part number 2 is going to be instant rate of change or instantaneous rate of change. And then the final idea is going to be limits. Okay? And one builds on the next, Okay? And they all sort of add together to sort of build the picture of what we're doing this week. Okay? So, firstly, average rate of change. Okay? This is essentially an idea that you should be pretty familiar with. Okay, once I start going through this, the maths and the logic should be pretty sort of clear with most people. Okay, so if I have a car and it's going from 10 meters, from 10 kilometers to 20 kilometers, and it's going at the same pace that's going to make a straight line. And if it takes 5 minutes to get there, okay, we have our x, we have our y, and our change in y, how far different our original y value is from our current y value over our x value, or the change in x, gives us the average change. Okay, so this triangle means change, means changing. Okay, it's called delta and it means changing. Okay, and here we can say, like our typical straight line formula, okay, our y value, or 20 minus 10, equals our change in y. And say this was at 0 and the 20 was at 5 units of time, you'd have 5 minus 0, which would equal 5. Okay, and m, our gradient, would be our change in x, our change in y over our change in x, which would be 10 over 5 or 2. Okay, and all of that average rate of change stuff should make sense when you're seeing it in a linear way. Okay, because the linear rate of change is constant. So if it's always changing at 2, your average rate of change is going to be 2. It can't be anything else. Okay, any questions or problems? Feel free to ask a question in the comments. Cool. Okay, next. If you have a line that is a function and moves up, okay, this change will also be your average rate of change for that function. So if you start at x1 and go to x2, okay, and this goes from 10 to 20, your average rate of change will be also the same as the gradient or the straight line between them, okay? Because it's an average. You'll notice that it's changing a lot less at the start of that, and then it's moving up a lot steeper than 2 at the end, but as an average, your rate of change will be the straight line between them, okay? And that's an important thing. Your average rate of change is equivalent to the straight line distance between 2 points. That straight line will be your average, okay? Now, it's a little bit of a demonstration, okay? If you take the purple line, or the red line as it might be, okay, if you take that line, you can see that that line's a lot less than 2, a lot slower than 2, because it starts off changing or having a tangent to the curve at a lot less than 2. And it finishes off at a line that's bigger than 2. So that one, x is greater than 2. That one, your rate of change is less than 2. But on average, across the thing, your rate of change is 2. Okay? So this is your average rate of change. Yeah? And it's essentially the straight line between 2 points will be the average rate of change. How fast it's changing on average. Okay? Now this works if the line goes up and down. Okay? Here, when it's going down, you'll find that the average rate of change is negative. And here, when it's going up very fast, you'll find the average rate of change is positive. Okay, but the two cancel out and give you the same average rate of change. Okay, the only place where the straight line doesn't work is if you go backwards and you get a line that doubles back on itself, because then you've got one group of x, another group of x, and you're counting the same thing twice, and that just all falls apart in maths. So your average rate of change in your textbook questions and all of that sort of stuff will be aimed at giving you 2 points at a time and you finding how far x, how far y, and the straight line distance between them. The other thing you might get is a question that goes along the lines of you're starting at 10, you go across for 5, and an average rate of change for 2. So you're going to have to go that you go up 10 things from 10 and you're going to hit that point 20. Those are the two sorts of questions that average rate of change tends to focus on. Cool. Okay, so if there's any questions on that, please ask. If not, I'll go on to instantaneous rate of change and then we'll start discussing limits. Okay, in fact, I might just do one average rate of change question. I'll put the question on the board and then, actually no, I'll just go on to instantaneous rate of change because I want to do a lot of time on limits. Okay. Keeps asking the question. Can you use Keith is doing the Keith has asked a good question. It took me a while to get my head around Keith's thinking. If you go up Red Hill, there is a speed camera here that measures at the bottom of the hill. And there's a speed camera at the top of the hill. Okay? And they're measuring 80 kilometers per hour as the speed limit. okay? And I think they're, for instance, say 1 kilometre apart. So you've got 1 kilometre, okay? And if you're going 80 kilometres an hour, it'll take you a set number of minutes to go from yo to yo, okay? So you might go slower and then speed right up, okay? You might go at nothing, you'll put on the accelerator and bang, speed right up. And in this instance, you've gone above 80 kilometers per hour as a speed limit, okay? But this is your average rate of change between the two. So if you take shorter than the time allowed to get there, they know that you've gone above the average rate of change at some point. You might be going the speed limit towards the end, but you were rocketing at the start well above the speed limit. And those average rate of change things are used by those speed cameras, and you can't really argue with them in terms of the maths. You can in terms of the speed camera didn't work, and it's a bit mean, but you can't really argue it in terms of the maths, because if your journey is sort of faster than the set amount of time, at some point your speed limit needed to be above the average. Doesn't get you out of speeding fine, Keith. Okay, next thing we'll move on to is the instantaneous rate of change. And the textbook's got a few questions and stuff about it. And it's more getting you used to the idea rather than a rigorous sort of maths approach to it. Okay? Now we're going to do calculus, which is, spoiler alert, the art of finding the instantaneous rate of change. Okay? And there's a mathematically rigorous way to do that. And you put a number to it and go, the instantaneous rate of change is 7. Okay, but we're going to do that later. So for now, it's just a more looking at what the instantaneous rate of change might be. Okay, and for that we have what's called a tangent to the curve. Okay, so just like I demonstrated before, this is no change at the bottom. And you can see that the red line is flat or has a zero rate of change. Okay, then for all of these instants, because it's flat and fairly straight, the average rate of change, the instantaneous rate of change is 0. But then you can see about there, it goes from 0 to 1 and it speeds up. The instantaneous rate of change speeds up, and you can see that because it's a curve, for every instant, the rate of change is different. Okay, that's what a curve does. For every instant, your rate of change is different. Okay? And then you can see by this one, it's going really fast, and it gets an average rate of change at sort of say 10, which is about the slope as this hits the point. Okay? And for the questions in the text that rely on instantaneous rate of change, you're going to need to sort of draw tangents and have a guess at what the instantaneous rate of change looks like. For you guys at the moment, there's no mathematically rigorous way to calculate that and go 7, 6, 3, and put a definite number to him. This is something that we'll do later in the course. Okay, so you'll have your average rate of change, okay, which is 2 points. You measure the across bit, you measure the up bit, and the gradient is the average rate of change, okay, and then you have your instantaneous rate of change, which is a sort of tangent to the curve. It's a place where it only touches once, okay? And all your instantaneous rates of change will add up to your average rate of change, okay? Any questions or problems that come out of that? Anyone going to be brave enough to ask something on the live stream? Cool. Okay, we'll press on and do what is probably the hardest and the most important bit of learning for this week, and that's called limits. Okay, so I'll just rub him off and we'll get started with that. Okay, for you to have an average rate of change that is meaningful, okay, you cannot have a gap. Okay? You can't have a gap in the line that's like this. This is called a piecewise function, and it's the sort of function that goes from here to here and jumps between the two. Okay? This function might be something like y equals the absolute value of x over x times 2. Nope. Sorry. Trying to think of a piecewise function on the fly. It's just not working for me today. Thought I had it written down, but I didn't. That makes me very sad. Okay? But there are some functions, like particularly around absolute values, that go on the bottom, then at 0, jump up. Okay? Actually, 4 to 1. So you sometimes have something like this. Y equals x minus 3 on top of the absolute value of x. Okay? Oh. keeps asking me velocity questions and using physics to confuse me in my maths lesson. Good on you, Keith. I quite like that. Okay? Keith, that's a good answer to that question. You should look that up. If you have something like this, let's just have a look at a whole series of values and how it relates around 3 and so on. Hello, Daniel. Okay. So, if you chuck so this is more interesting if you put the absolute values on the top. If you chuck 1 into this equation, you've got 1 minus 3 is 2, minus 2 on 1. Okay? Sorry, so if you chuck 1 into this equation, x equals 1, you end up with minus 2 on 1. Then you chuck 0, you end up with, then you chuck 2, you end up with minus 1 on, you end up with 2 on 1. Sorry, I should have written down my piecewise function to illustrate it. I'll do that afterwards and put it there. I've never been good at sort of absolute value stuff and piecewise functions. Okay, cool. So to go back to where we were heading. Okay. Some functions, particularly around absolute value, will have a gap where they jump up, okay? And it's impossible to find an average rate of change between that gap, okay? The main reason being if you start off here and go to there, that's your average rate of change. But your average rate of change becomes infinitely big and impossible to determine as you get closer and closer and closer to the jump, okay? The other problem in average rate of change is that if you have a function like, the my phone that I'm using to record is ringing. Okay, if you have a function that's like, sorry, I might answer that. That pushed me off. I will continue the live stream tomorrow. Sorry, guys. Feel bad about that, but I should probably sort of deal with the phone call. Sorry, guys.